Hello and welcome to Solving Trig Equations Graphically, Part 1. What I'm going to do here is I'm going to show you a method. Here's my first example, and we're going to show you a method of solving this thing using technology. And that technology could be a graphing calculator, which is what I'm going to use. It could be a laptop that has some graphing software on it. So these days, just about anything with some graphing software will do the trick. So let's have a look at this first example, show you what it's all about. It says, given this function here, h, which is the height of the person on the Ferris wheel, so height equals 15 times cosine of pi divided by 20 times t minus 20, so time, plus 17. And presumably this is the time in seconds that a person has gotten on the Ferris wheel and it's spinning. So here comes the question, when is a rider at a height of 18 meters during the one revolution, or let's say the first revolution? So really what we're talking about, let me just give you kind of a little picture idea of what's going on, and then the strategy I'm going to use. So what I'm going to try and do is produce a graph that will look something like this. Now here's just a rough idea. Person starts, and then presumably they go up the Ferris wheel. Their height increases, and then it goes back down. Whoops. And this will continue forevermore. And we want to know when is the height here. Let's say it's along here. At what time do they hit 18 meters here on the way up, and then 18 meters here on the way back down? That's the question. We want to know what are the times. So in other words, what is the time on the way up that we hit a height of 18, and then here, what's the other time on the way down? Now there's a couple of different strategies for this. The easiest, I think, and the clearest is to do the following. We're interested in a height of 18, so we're going to replace h with 18. That's, after all, the height that we're interested in. So in my function, I put in 18 for h. And take the rest of this stuff, okay, I don't think I'll write it all out, and because that looks the same as I've got up here. And then I'm going to use a little trick. I'm going to make this a 0 on the left side. So I'm going to take 18 away from both sides and make that 0. Now that's going to change things a little bit on my function over here, because at the end here, see where we got plus 17? Well, if we subtracted 18 from that, we'd have had a minus 1 now at the end. Now why would I do this? Well, it does change my graph a little bit, but it makes it easier because now if I go ahead and I graph the following function, y equals da-da-da-da-da, okay, with this minus 1 now, I'm looking for those points that have a y value of 0. That's what I'm after, okay? And that really means I'm after the x-intercepts of the graph, because those are the points where the y value is now 0. So I'm going to graph this function, and then I'm going to find the x-intercepts. So let's pull up the graphing calculator, and I've already, I hope, see if it's there. Yes, it is. I've already put in my function. So if you see, look what I got here. I got the 15 times cosine of pi divided by 20. And now if I just move it along here, I'll just show you what I got on the other side. It's kind of important. I put in the x, then the minus 20. Now I got to put in 2 brackets. And the reason for that is because the first bracket is to close up the x minus 20. The second bracket here is to close up everything that's being cosigned. And then at the end of that, I got my minus 1. Okay. Next important things before you go ahead and graph it is you got to make sure that you're in radians. So here I can see there's radians and it's shaded, which means that's good. Then I got to change the window settings. Now this is a way of saying I got to set the domain and range to get a good picture. And I'm thinking the domain might start at 0 and go to about 60 is what I put here. So it runs about 60 seconds. This scalar business here, what that means is that the little markings along the x-axis, they're 10 apart. So it would go 0, then 10, 20, 30, 40, 50, 60. For the y minimum, I've started it at -5, and I went to a maximum of 50 and a scalar of 10. So I just figured that might make a pretty good graph. So let's hit graph now and see if we got it. Hey, there it is. Now you'll notice it's different from this little crude drawing here, and that's because we subtracted the 18. It's kind of pulled the whole graph down, and our goal is to find these x-intercepts, right? These are the 2 points that I want. So how do I do it? Well, I go second, trace, and there are zeros on these calculators. They're called zeros, which means the same as an x-intercept, so I choose that. And then it gives you this funny left boundary thing. Now what I'm going to do is I'm going to move my cursor to the left. And what I want to do is tell it that there is an x-intercept somewhere between, and so this is the left boundary part of it, somewhere between, so let's hit enter, that point. See how it's put that little triangle there? It says, aha, from there to, now right boundary, you want to move your cursor till you've moved it past your x-intercept. So that looks good enough, so we'll hit enter. And now you see what you've told the calculators, between here and here, there is an x-intercept. When it says guess, I just hit enter one more time, and there's my answer, 10.42. So that's the first time that corresponds to a y value of 0. Now this funny number here is actually 1.1 times 10 to the negative 12, which is very, very small, and as far as the calculator is concerned, that counts as 0. Sometimes it does this kind of funny hanging decimal calculation, but if you see a really tiny number like this, we consider that to be 0. So there's one of my solutions. Now I'm going to find the other, and I'm just going to repeat the process. So second, trace, and I choose 0. I move my cursor somewhere on the left side. Doesn't really matter where, as long as it's on the left side of this x-intercept. So that looks pretty good. I'm going to hit enter. Then I'm going to move it past the x-intercept. So that looks pretty good. And then instead of guessing, I'll just hit enter one more time. And I get 29.58. So here's my two answers. So I'm going to write them down. 10.42. And the other one was 29.58. And we were able to do that by simply producing a graph and finding the x-intercepts. That's probably a pretty good place to stop, and I'm going to come back with a couple more examples just to show you the different things you can do with your graphing calculator. So we'll see you in a little bit.